Red meat is bad for you. Red meat causes cancer. You hear it all the time. But are these claims really justified? This notion that red meat causes cancer comes from the 2015 decision from the International Agency for Research on Cancer, also known as IARC. They declared red meat as a Group 2A carcinogen. Group 2A carcinogens are considered probably carcinogenic by IARC. They used a meta-analysis compiling over 800 epidemiological and controlled studies as their reasoning. This study also claims that there is strong mechanistic evidence that red meat is a carcinogen because of a few compounds found in red meat. First, it must be noted that epidemiological studies are done by questioning a group of individuals over several years. In nutrition science, this typically means a food frequency questionnaire every few months. This method of data collection is inherently faulty because most people do not track what or how much they're eating. There are also confounding variables that affect results, like how physically active the subjects were, how much they smoke, how much sleep they get, amongst others. A much more reliable method of data collection would be to give subjects certain diets in a controlled environment and measure the outcomes. In fact, that data does exist in this meta-analysis, specifically stating that out of the 15 controlled trials they analyzed, only 7 found a positive association with colorectal cancer, the cancer we most often hear about when it comes to red meat. When looking at the questionnaire-based studies they reviewed, they found a 17% increased risk in developing cancer with a high consumption of red meat. This may sound like a decent increase, but it is hardly convincing even if the data was reliable. Consider that the epidemiological study that found that smoking cigarettes increases the risk of lung cancer was between a 1,500 and 3,000% increase in risk. Even then, this study technically does not prove causation. The correlation is just so strong that most of us consider it to be the cause. It's also important to consider that this paper explicitly states that they valued the questionnaire-based studies over the controlled trials, which seems counterintuitive. Even with all of this considered, the paper states, chance, bias, and confounding could not be ruled out with the same degree of confidence for the data on red meat consumption, since no clear association was seen in several of the high-quality studies and residual confounding from other diet and lifestyle risk is difficult to exclude. The working group concluded that there is limited evidence in human beings for the carcinogenicity of the consumption of red meat. They basically admit that there is no conclusive evidence that red meat is in fact a carcinogen in the very paper that IARC used to classify red meat as a carcinogen. Still, the idea persists today based on other mechanistic reasons. Mechanisms are great. They give us an understanding of how things happen in the body and are important in the treatment and prevention of disease. The problem is, people will sometimes only look at mechanisms, not realizing that the body is incredibly complex and there are interactions between mechanisms. This is why endpoints are the most important thing to consider in nutrition science. For example, we shouldn't be looking at the mechanism of cholesterol in developing heart disease and assuming that eating cholesterol causes heart disease. We should be looking at if cholesterol intake directly increases risk for heart disease. The first mechanism people seem to be concerned with when it comes to red meat is its effect on mTOR and IGF-1. mTOR is a signaling pathway that triggers cell growth and proliferation, and IGF-1 is a growth factor that will stimulate mTOR. Overactivation of mTOR is known to facilitate the growth of tumors, and since some amino acids in red meat activate mTOR, people use this as a reason to avoid red meat. mTOR also inhibits the process of autophagy, where cells will use old useless proteins for energy. Autophagy has been identified as a key component in longevity. However, it's important to note that mTOR isn't inherently bad. We need mTOR to grow muscles and other tissues. The ideal situation would be to be in a perfect balance between growing cells, creating cells, and dismantling old ones. Cancer and aging are only accelerated when mTOR is overactivated. The problem with cancer patients is that they more often than not have a genetic mutation of genes that regulate how much mTOR gets stimulated. With these genes not functioning properly, mTOR is chronically overactivated, providing tumors with the perfect environment to grow and spread like wildfire. If you don't already have this mutation, you really shouldn't be concerned with red meat activating mTOR to the point of developing cancer or making you age abnormally fast. Even if you do have this mutation in your genome, meat is highly satiating. Eating meat-heavy meals won't have you wanting to snack on some ground beef every few hours. Here we can see that while mechanisms are certainly important, they cannot be looked at through a narrow lens. Context needs to be applied. One compound that's gotten a lot of attention for its supposed contribution to heart and kidney disease is trimethyl N-oxide, or TMAO. TMAO is either directly obtained from the diet or is created by certain gut microbes upon metabolism of carnitine or choline. Red meat is high in carnitine and eggs are high in choline, so this may be cause for concern. Let me start by pointing out there was a meta-analysis looking at 20 different studies and over 1.2 million people that found no relationship between red meat consumption and risk for heart disease. Of course, this is only a piece of the puzzle, but it is interesting to see how little attention a study of this magnitude was given. What many people don't acknowledge is that eating fish will yield by far the highest amount of TMAO, significantly more than the consumption of beef or eggs. This is because fish actually have preformed TMAO in their flesh. TMAO has been linked mechanistically and in epidemiology studies to increase the risk of heart disease. However, by these same metrics, consumption of fish has been repeatedly linked to lower risk of heart disease. It is plausible to consider that eating fish has some other benefit that outweigh the risk of TMAO, but as previously discussed, there is no correlation between red meat consumption and heart disease. The other thing to consider with TMAO is that besides consuming fish, TMAO is primarily generated by microbes in the gut. Which microbes are generating the most TMAO? This study found that those who produce higher TMAO have a 2-to-1 ratio of Firmicutes bacteria to Bacteroidetes, while those that produce less TMAO have a 1-to-1 ratio of these two bacteria. As Alana Collin details in her book, 10% Human, when lean people are put on a high-calorie diet to induce weight gain, they see an increase in the amount of Firmicutes bacteria in their gut. This would suggest that high TMAO levels are a result of an unhealthy gut microbiome that came from a diet that causes weight gain. This theory is further supported by a clinical trial study. This study found that taking rifaximin, an antibiotic shown to improve the ratio of these two bacteria, also led to lower levels of serum TMAO. So TMAO is either harmless or it could cause a problem due to poor gut microbiome composition, likely caused by a poor diet. People who believe red meat is bad also may bring up the fact that heterocyclic amines and polycyclic aromatic hydrocarbons lead to cancer. These compounds are produced when meat is cooked. This doesn't add up from a common sense standpoint, considering humans have been cooking food for around 500,000 years. Humans were eating raw meat for at least 1 million years before this as well, but it's safe to say that humans cooking meat is nothing new. The only real evidence for these compounds being carcinogenic is from mice studies, poorly done mice studies, that is. Even the National Cancer Institute's website states that these studies involved giving these animals thousands of times the amount a human would be exposed to in a normal diet. Even if you're Sean Baker eating 4 or 5 pounds of cooked ribeye per day, you wouldn't come close to this amount. If you were to completely black all of your steak when cooking it and eat about 10,000 pounds of it over the course of the day, then yeah, you might get cancer. In other words, it's about as likely as overdosing on marijuana. The final compound we'd like to discuss is Nu5GC. Nu5GC is a sugar that binds to the outside of certain cells in our body upon ingestion. Most other mammals make Nu5GC, so red meat has a good amount of it. Humans, plants, and microbes do not produce any Nu5GC. The main concern from Nu5GC is that it's been found on cancer cells, and the body actually produces inflammatory antibodies against Nu5GC. However, does this mean that Nu5GC causes cancer and is a risk for developing autoimmune disease? Diving into the research, the story of Nu5GC is quite interesting. Somewhere in human evolution, we swapped Nu5GC expression for a similar molecule, Nu5AC, which is almost exclusively expressed by human cells. So what would be the purpose of making this change and actually provoking an immune response when Nu5GC is present? Pathogens of all kinds can bind to Nu5GC or Nu5AC and proceed to make their attack via endocytosis, the process of entering cells. The current research suggests that cholera and certain influenzas can only enter cells in this manner if they bind to Nu5AC, but can't if they bind to Nu5GC. This explains why these infections are basically exclusive to humans. Studies have shown that ingested Nu5GC is actually protective against these infections. The viruses can bind to the surface, but ingested Nu5GC will most likely be excreted within 8 hours, so it can act as a trap. Since these pathogens can bind to but not enter cells with Nu5GC, it's very likely that some dietary Nu5GC will already have a microbe clinging to it. This is likely why we produce an immune response to it, not because of the Nu5GC itself, but to protect against any passengers it may be carrying. If we didn't develop this immunity to Nu5GC, pathogens that are bound to Nu5GC from the diet would be able to run amok in the body. Since humans are one of the only mammals that eat other vertebrate meat, and also one of the only animals that don't express Nu5GC, we separate ourselves from the pack and gain an advantage. This gives us a double-layered defense mechanism. We get protection against pathogens that bind to Nu5GC, but also don't have to worry about these pathogens entering our cells that express Nu5AC. Another interesting note about Nu5GC is that the only human cells that do express it are tumor cells. People are worried that Nu5GC is carcinogenic, but it needs to be acknowledged that it's not the Nu5GC that causes the cancer, but the cancer that causes the Nu5GC. In fact, this study found that when people were given Nu5GC, there was no increase in risk of colon cancer. So yes, we may have a short-term immune response to Nu5GC before we excrete it, but that's a pretty good trade-off for protection against meat-borne pathogens and another way to recognize tumors. The question then becomes, if you are constantly exposing yourself to this inflammation from dietary Nu5GC, are you at risk for developing an autoimmune condition? After all, autoimmune disease starts with an overly stimulated immune system that ends up attacking normal tissues. What's important to note is that more than half of our immune cells have receptors that recognize healthy cells. The body has several complex mechanisms to make sure that these immune cells don't spontaneously start attacking the body for no reason. If not for this, autoimmune conditions would be universal. However, several factors could inhibit our body's ability to stop these immune cells from attacking. Dr. Paul Mason describes his Swiss cheese model of autoimmune development in his talk on plant lectins.
So it's probably time to pause for a moment and ask why not everybody has an autoimmune disease? Because we've all consumed lectins in the past, right? So I find it helpful to apply the Swiss cheese model of accident causation here. And that states that accidents only happen when deficiencies in the defences line up. So if we have a think about autoimmune diseases, you need to pick the wrong parents. You probably need to have some aspect of intestinal permeability, which may or may not be triggered by lectin consumption. And then you may also need to be consuming lectins or have some other kind of antigenic stimulus like certain bacteria within your gut. So unless all of those three line up, then chances are you probably won't develop an autoimmune disease. But for people that have picked the wrong parents, these next two layers become very important.
An interesting point Dr. Mason makes is that on leaky gut. This is a condition where the cells lining the intestine become separated, allowing components of the diet into the bloodstream and potentially causing inflammation. Several factors can cause a leaky gut, but it's highly unlikely that red meat is one of them. It's generally believed that an unhealthy gut microbiome is a key contributor, as well as certain components found in plants such as lectins and gluten. Chris Kresser explains a potential reason of why a meat-only diet could actually help with a leaky gut.
So this is just a theory. I have nothing to, I don't have any evidence, but when meat is absorbed very high up in the digestive tract. And so when you only eat meat, it's a low residue diet, and there's nothing left over to irritate or inflame the gut. My theory is a lot of people who are benefiting from this have a really disrupted gut microbiome. Alessio Fasano has argued that leaky gut is kind of a precondition for autoimmunity. And the carnivore diet is essentially like a gut rest or a fast.
So yes, new 5GC can be a factor in developing an autoimmune disease, but you'd also have to have poor genetics and already have to be metabolically unhealthy for new 5GC to even start to matter. Considering how many people have reversed their autoimmune conditions by eating only red meat, it's safe to say you shouldn't be concerned about new 5GC from meat if the rest of your diet is clean. So all in all, red meat isn't really the bad guy it's been made out to be. Context is the most important thing to consider when evaluating its potential damage. If you're constantly eating red meat in the form of Big Macs with a side of fries and a soda, it could contribute negatively to your health. But by itself, red meat is one of the most nutrient-dense foods on the planet, and I'd argue it should be a component of everyone's diet.